Now that we've defined centripetal acceleration, we can define a centripetal force, which honestly, it's almost not even worth giving a centripetal force its own name, but the books typically do it. So let's follow up with that here. We know that. So let's actually go back to kind of this example, like a rock whirling around on the end of a string, like this. It's going around in this circle, like this. We know that in order for this rock to go in a circle, it must be accelerated towards the center. And we know that an acceleration is caused by a net force, right? So we have to have a net force, sum of forces, is equal to mass times acceleration, right? So if we have a centripetal acceleration, like this one, this must have a very particular acceleration, which is towards the center of the circle. Then we have what causes that centripetal acceleration is a centripetal force. So I'll just say Fc, the centripetal force, is equal to the mass times the centripetal acceleration. Really, it's just, F equals ma here for a particular acceleration, so we have a particular force. But just because it has its own name, don't let it fool you that there's some new force we're introducing. Like there's this force we didn't talk about before that's we need to introduce here. This is centripetal force. There is no new force here. It's simply all the forces we've introduced previously may act as a centripetal force. So, for example, if we have the rock on the end of the string here, the force which provides the acceleration towards the center is the string. So the tension in the string acts as the centripetal force in the next example. So I'll say here, centripetal force is equal to the tension in the string. If we have, let's say here, the Earth, here's the Earth here, E, and then we have the moon going around it. There's the moon. Then the moon goes around the Earth in a circular or sort of circular fashion, right? So something like this. And so because this is going in a circular motion, it has to have some centripetal acceleration. Therefore, it must have some force providing that centripetal acceleration or a centripetal force. In this case, it would be a gravitational force, the pull of the Earth on the moon. So in this case, our centripetal force would be the gravitational force. Gravitational force. So it's not a new force. It's just some other force playing the role of a centripetal force. Let's say we have like a car going around a curve like this. Then let's say we have this car is going around a curve like this. So it's turning to the left here, so it must be accelerated inwards this direction, the centripetal acceleration. So what provides a force to the left? Well, the only forces we have are that act in this x direction would be the frictional force. So the centripetal force is the frictional force in this case. So friction plays the role of the centripetal force there. Same thing if we have a centrifuge, like over here. Like we have this one, there's a little particle right here moving off in this direction. If this is going to continue going in a circle, then it must be accelerated towards the center, and so it would be the normal force from the end of the test tube right here pushing that direction. The normal force would be would provide the centripetal force needed. So centripetal force, not a new force, is simply provided by other forces here. We could also have magnetic forces, electrical forces, could be centripetal forces depending on the circumstances. So with this said, there's nothing really new to solving problems with centripetal acceleration. We draw a free body diagram and some forces F equals ma, whatever forces cause whatever accelerations. So if we come up here like this car going around a corner, maybe I would draw a free body diagram so I have my positive x going this direction, in the direction of the centripetal acceleration. And I'm taking just a snapshot right here. It's really, I just take a snapshot of when it's going around the curve. If I wanted to find out what forces are present here required for this acceleration, then I would do a free body diagram when it's right here. My y would come straight out of the screen here, and so a free body diagram of this car, and that when it's going around the circle there, I would have or not even a full circle, it's going around just a part of a circle. It doesn't have to be going fully in a circle. It could just be some fraction of a circle, as long as it's going through an arc. We have some centripetal acceleration. We had some weight acting down here. We had some normal force acting up here. And we know that it must be accelerated to the right in order to go in this circular motion. Otherwise, it would just move off in a straight line, V, tangent to the curve. And so then the only thing which could provide the centripetal acceleration would be a frictional force. And so the frictional force must push it like this, off to the right here. So yeah, centripetal force, not a new force. It's just other forces playing the role of the centripetal force to provide the centripetal acceleration.